All right, still continuing with our quadratics, but this time we're going to look at some word problems. And our goal today is I can use completing the square to solve maximum and minimum problems. Remember, when a parabola is in vertex form, we can tell whether it opens up or down, so we can tell whether it has a minimum or a maximum value. And so that's what we're going to do now with actual word questions. So, maximum min word problems. Here's our question. For training, astronauts use an aircraft to simulate weightlessness. The flight of the plane can be modeled by the equation h at t equals negative 10t squared plus 300t plus 9,750, where t is the time since weightlessness was first achieved. So our first question is, what is the maximum altitude of the flight? So as soon as I see the word maximum or minimum, I know that I'm going to have to complete the square. What's different about word questions is we have very large numbers, usually not very nice numbers, as you can see here with the 9,000 number here. So the first thing we're going to do is we're going to copy down our equation, okay? And we're going to treat it the exact same way as we did before. We're going to put a bracket around the x squared term and, sorry, the t squared term and the t term. The next thing we're going to do is we're going to factor out that negative 10. Now, when I factor out negative 10, what I'm left with then is t squared. And watch your signs here. It's going to be a negative 30t. Okay? Now, just like we did from the previous lesson, we're going to take half of 30, which is 15, and square it. Now, if you don't know what 15 squared is, then you would pull out your calculator and you would actually calculate it if you needed to. Most of you should know it's 225, but if you don't, that's what your calculator's for, and it would tell you it is 225, just like I told you it was. So we end up we're going to add 225, but we just can't add something, we also have to subtract it. And we still have our large number at the end. Okay, so remember the first three terms are going to be our perfect square. And then we're left with this negative 225. So we're going to take negative 225 and multiply it by negative 10. So it's going to be a positive 2,250, and we still have our 9,000 number. Our first three terms go into a perfect square mode, and it's a matter of cleaning this up. So when we add these together, we end up with, and I believe it is, and I'm not going to just guess, I'm going to clear it and find out, 250 plus 9,750. So we're looking at 120,000. Is that right? 1, 2, 2. That's what I get. And I think in my answer I am missing a 0. Oh, 3 zeros. I got the same. Okay, so what does that mean then? If we actually look at this as far as if I graphed it, and I'm just going to reveal this and talk about it for a second. So what we found with this question is, number one, at time is 0, we're starting at 9,750. Okay, and we know that that's the y-intercept from up here. Okay, we know that the vertex is at the top here, which happens at 15 and positive 12,000. Okay, and so remember, that's our t, that's our h. So that's what we found out. So what was the maximum altitude? Well, the maximum altitude was 12,000. And I think it was feet, was it? Or they didn't tell us what it was. So we can put the maximum altitude was 12,000. And I did put feet here, even though the question didn't say it was in feet. Okay, so the next question dealing with this is, how long does it take to reach the maximum? So how long does it take to get up to that top? Well, I can see it's the vertex, it's 15. so 15 seconds. Then it says, at what altitude do they reach weightlessness? I'm not sure. So let's take a look at the question. It says, where t is the time since weightlessness was first achieved. So that means it happens right here, okay, at t equals 0. So we know that that occurs at the y-intercept. So that's going to be 9,750 feet. Now, the next question asks, weightlessness is lost at the same altitude it was achieved. How long does it last? Well, if we go back to the little diagram that we drew, this is where weightlessness was achieved. They're telling us it loses it at the same spot. So how long was that? Well, I know from here to here was 15. So how long is it from here to here? Well, we know the parabolas, first of all, are symmetrical. So it would make sense that if it took 15 here, it would have to take 15 here as well. So for our answer, we're going to put, because of symmetry, just double the 15 seconds to reach maximum height. So it lasts 30 seconds. Okay. Now, if they said that it reached it down here, we couldn't do that because we didn't know what the x-intercept was at time as a negative number. Okay, so let's look at one more question together. Okay, the next question says, a theater company has 300 season ticket subscribers. A survey shows that for every $20 you increase the price, okay, so which is now $400. So we're starting at $400. So every time we increase it for 20, they will lose 10 subscribers. What price will maximize their revenue? Okay, now what's different about here, they didn't give us the equation, so that means that we're going to have to do a little bit more work here. We see the word maximize, so that we know that we have to somewhere along the line complete the square. So let's talk about first about revenue. We know that the way that we make money is it's the number of subscribers times the price, right? So if I have 10 subscribers and my price is $400, that would mean I would make, my revenue would be 4,000. Okay. Now that's not quite our situation here. We also are going to let n be the number of $20 increases. So we know the number of subscribers each time is going to equal the 300, which we had, minus 10 times n. So every time we increase the n, we lose 10. Okay? But at the same time, I know my price is going to change. It's going to be the 400, and I'm going to add $20 times the n. Okay, so the number of subscribers is 300 I'm starting with, and I'm going to lose 10 every time I increase something. My price is always going to be 400 plus 20 times the number that I increase. So I have two equations here. So my revenue, remember, is the number of subscribers times the price. So here's my number of subscribers. So my revenue is going to be the 300 minus the 10n, and my price is going to be the 400 times 20n. So what's different about this one, it's actually in almost factored form. So what I have to do first of all is I have to expand this. So 300 times 400, so we're looking at 120,000, and 20 times 300, and then minus 4,000, so we're looking at negative 2,000 n, and then negative 10 times the positive 20n, so we end up with a negative 200n squared. So now I do have a trinomial. However, it's not in the form that we usually put it. So what we're going to do is we're going to rearrange it and start with our n squared first. Remember, n squared is a negative 200, so make sure you bring that negative with you. And we then have our n term followed by our constant term. Now what we're going to do is we're going to complete the square of this the exact same way as we did before. So it just added another layer to our questions. All right, so when I take out the negative 200, when I take out a negative 200, what I end up with is n squared and minus, what's your signs again, minus 10n. And then we're going to add half of the negative 10 squared, which would be 5 squared, which would be 25. I can't just add 25, I have to subtract 25. And I also have my positive 120,000. The first three terms are going to be our perfect square. When I take out the negative 25, I must multiply it by the negative 200. So again, if you can't do that in your head, what you would do is you pull out your calculator again. So we have negative 200 times negative 25. So we end up with a positive 5,000. So we're adding 5,000 and we still have our 120,000. All right. So really what we have here is we have gained, that's the amount that we've gained, 5,000. Okay, and this is the old revenue that we had. Okay, so our old revenue from way back here was still 120,000. We gained 5,000. So let's finish up the question here. So first three terms are the perfect square. So we take half of the 25 and take the square root of it. So it's negative 5. And we clean this up. And so we end up with 125,000. So the maximum that we would have would be 125,000. And it happens after I've made 5 increases in the price. Okay, so the maximum revenue is 125,000 if we increase the price by $20 5 times up to $500, because 5 times 20 would be 500. Would be 100, and we started with, in this question, 400 was what we had at the beginning. So if we increase it by 500, we'll make more money, even though we will lose some customers. Okay, some word questions for you to work with. Make sure that you're working with your group, and remember, I'll be around to answer any questions.